predicting the direction of a reaction. We predict the direction of a reaction by comparing the Q, the reaction quotient, with the equilibrium constant value. If we compare in the QC, then if we consider the QC, then we must compare that with the KC value. If we compare we have the QP value, the reaction quotient obtained by the pressure values, then this must be compared with the KP value. Right, what is the relationship? If let me draw a diagram, a graph like this. If the Q less than K, it's something here, Q less than K, then the reaction will move forward and like from left to right and make more products, more products. If the Q equals K, the system is in equilibrium. There will be no net reaction. The forward reaction rate equals to the reverse rate reaction. If the Q is greater than K, then reaction moves backward from right side to left side, making more reactant. So it makes more reactants. That's how we decide the direction of a reaction by comparing the reaction quotient and the equilibrium constant values. Here is an example, a practice problem. At 375 degrees of Celsius, the equilibrium constant for this reaction for the production of ammonia using N2 and H2 gas is given as 1.2. The reaction is balanced. Good. At the start of a reaction, the concentration of N2 is 0.071, H2 9.2 times 10 to the negative third molar, and the concentration of ammonia was 1.83 times 10 to the negative fourth. Determine whether the system is at equilibrium, and if not, determine in which direction it must proceed to establish the equilibrium. Right. So we don't know, these are not the equilibrium concentration. It didn't mean, but we are given the equilibrium constant, but these concentrations were not listed as equilibrium concentration. So what do we can calculate? Yes, the reaction quotient, the same expression as the equilibrium constant, but instead we can use any concentration. We don't need to apply the equilibrium concentration. So we plug those concentrations value and we found the QC value. So the QC value is less than the equilibrium constant. What is the equilibrium constant? Yes, the equilibrium constant was 1.1. So that is less than equilibrium constant. Yes, QC less than K. So what's that mean? Yes, the reaction will move forward, making more products and establish a new equilibrium. It will come to a new equilibrium.